Hello folks, we are coming to the exercise 3.3 part 3 now. In the previous question we were doing prove that, but then we did two find questions. Now we are coming back again to prove that questions. They have asked us to prove certain thing. We are going to prove it by whatever formulae and values that we know. We will be doing it. So let's take this question number 6 right away. They give us cos pi by 4 minus x into cos pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y. All this is simplifying, and you should say that it becomes sin x plus y. How do we go about doing it? That's a question. Now, can be done in many ways. All right, one way, probably a little more simpler way should be, when we observe this, do we see anything on observation? Do we find anything quite striking? Yes. What is it? What we observe, the angle that is there here is the same angle here. If this is some angle A, then this is also angle A. The angle here, if we choose to call it B, then that B only is there here. So basically it's like of this type. It's like of the type cos A cos B minus sin A sin B. Is that correct? Now, is that familiar to us? Yes. So what we are going to do is right away, let's consider the LHS. And in the LHS, we have considered that the left hand side is of this type, cos A cos B minus sin A sin B, and we have learned from our formulae that anything that is of that type is called as cos. It's cos A cos B minus sin A sin B, so it's going to be cos A plus B. So that is our value, cos A plus B. So here we are going to use the same formula. LHS now is no longer that huge thing, but it is reducing to cos A plus B. A for us is pi by 4 minus x, and B for us is pi by 4 minus y. It's just that much. Okay, so then we can do our clubbing. Pi by 4 plus pi by 4, 45 plus 45, 90. Otherwise, pi by 4 plus pi by 4, denominator same, add the numerator, 2 pi by 4, pi by 2. That will, so it's okay. So here it is cos pi by 2 minus x plus y. Yeah, there's no harm. We can call it like this. Now, this is our good old friend which we have had it in the 10th standard complementary angle. We have learnt cos 90 minus theta is sin theta. We have learnt it. So, because of this, we know that cos pi by 2 minus x plus y is going to be sin x plus y. Why we know it? We know that because pi by 2 minus theta is always going to be sin theta. By our 9th standard, we have learnt it now also, but by our 10th standard logic, we know it, and that's how it has become sin x plus y, which is our RHS, and that's how we have proved the result. Hence proved. We've proved the result. So that's about this. Let's quickly go to the second question, 7th question. It says that it is tan pi by 4 plus x by tan pi by 4 minus x should work out to what is there over there. Right away, let's consider the LHS. Tan pi by 4 plus x by tan pi by 4 minus x is not much option left with us rather than using the expansion. Tan A plus B formula and tan A minus B formula. Tan A plus B. How does it expand? It becomes tan A plus tan B by 1 minus tan A tan B. And so also its counterpart, tan A minus B is tan A minus tan B by 1 plus tan A tan B. So let's apply this. Here it will be tan pi by 4 plus tan x. How? By using the formula 1 minus tan pi by 4 into tan x. That's just the numerator. Now let's go to the denominator. It is tan pi by 4 minus tan x by 1 plus tan pi by 4 into tan x. And let's solve this. Tan pi by 4 is tan 45. We all know it's 1. So let's substitute 1 plus tan x by 1, because this will become 1. So it is 1 minus tan x. That's our numerator. Now denominator 1 minus tan x by 1 plus tan x. So this is divided by this expression. Whenever we divide by an expression, we multiply by its reciprocal. So this will get multiplied here, this will get multiplied here, and you will get 1 plus tan x into 1 plus tan x, that is 1 plus tan x squared, and 1 minus tan x into 1 minus tan x, that is 1 minus tan x whole squared. And that luckily is our RHS, and that's how we prove the result. Hence proved. That's how we prove this result. Now let's go to the next. Is a pretty easy one, not so tough. Cos pi plus x, cos minus x, sin pi minus x, cos pi by 2 plus x, all that is working to this particular expression. Now before we actually jump to the LHS, let's consider these term by term. Cos pi plus x, where does this lie? Which quadrant? Pi plus x is in the third quadrant, and third quadrant is not the quadrant for cos, it's a quadrant for tan and cot. So cos becomes a guest there. Like that, it will definitely, whatever is the answer, it will carry a negative sign. Now how do we go for the carrying of the for the trigonometric ratio? We drop it. So what we are getting? Cos x. So it is coming to minus cos x. When we solve it, we will get minus cos x. Next term is cos minus x. We learned yesterday that if it is cos minus x, there is no harm if we call it as cos x. That's how we have the formula. Then next term is sin pi minus x. How about pi minus x? Which quadrant does it lie? It lies in the second quadrant, and second quadrant, the host is sine and cosec. So because they are sine and cosec, they will definitely carry the positive sign. As a result, in the conversion, you will definitely have a positive sign, and we drop this pi, we get sin x as the answer. That is how we have the conversion for this. Then the last term, it is cos pi by 2 plus x. Where does this lie? Pi by 2 plus x. Second quadrant, pi by 2 plus x will lie in the second quadrant, and second quadrant is a quadrant for sine and cosec. Because this is cos given to us, definitely our conversion will carry a negative sign. So we have the negative sign. Now we have to be little careful. See, pi and 2 pi, they are totally trouble-free functions. Your conversion becomes very easy. But whenever this pi by 2 or 3 pi by 2 comes into the picture, you have to be careful about the conversion. That is, here when we had pi, we just wrote this remaining value sin x, we got the answer. Wherever pi was coming, we were writing like that. Even 2 pi is there, we can write it like that. But the moment pi by 2 or 3 pi by 2 comes, this ratio will reverse, and it will go to its counterpart. Cos will go to sine, tan will go to cot, sec will go to cosec, and other way around also. Sine will go to cos, that way. It will interchange. So there is a ratio interchange. So because it is pi by 2 over here, there is a ratio interchange, and here it will become now minus sin x. So that you should be careful. So this is what the conversions amount to. Now let's go to the LHS. Now the LHS will become, let's put all these values, substitute. Cos pi plus x is minus cos x. Cos of minus x is cos x. We have solved it. And sin of pi minus x, we have learnt it as sin x. And cos of pi plus 2 is going to be minus sin x. The minus, they can cancel each other. And you have the numerator now, cos x into cos x, cos squared x. Sin x into sin x, sin squared x. Cos squared x by sin squared x, we all know is cot squared x, and that is the RHS, and that's how we prove our result. That's how we prove our result. So this is about our part 3 video. The remaining questions we are taking it up in the part 4 video. Thank you.